Welcome to Precalculus Concept 16a. We're talking about rational functions and their graphs, and this particular video is going to focus on finding the domain of a rational function. We got 4 boxes to cover, so let's get going right away with box number 1. What I'm going to do is introduce to you in general what a rational function even is, alright? So for us, a rational function is going to be a function that is in the form of f of x equals some fraction. Since it's a rational function, it should look kind of like a rational number. And instead of the quotient of 2 integers like a rational number is, it's going to be the quotient of 2 polynomials. So we're going to have some polynomial p of x up here and some polynomial q of x down here. So this is what it looks like in general, and one specific example could be something that looks like this. F of x equals 3x over x squared plus 2. In this particular case, this is a rational function because it is the quotient of 2 polynomials. The 3x represents the p of x, and the x squared plus 2 represents the q of x. So this is what a rational function is, and moving forward, whenever we say the term rational function, we are defining 2 polynomials being divided by each other. Box 2 is an example, and this represents the very first skill that we need to acquire in dealing with rational functions. And that first skill is to find the domain. Okay, so I have 3 rational functions here. I have a, b, and c. Let's start with a. You'll notice that I have x squared minus 9 divided by x minus 3. The numerator represents the p of x, and the denominator represents the q of x. So the way that we find a domain is we look at all values of the denominator, or q of x in this case, that would give us a possible 0. So, hopefully you guys see that if I took x minus 3, which is the value of q of x, and I set it equal to 0, and I solved, I would get a value. I would find out that x is equal to 3, okay, by adding 3 to both sides. The reason that this is bad for us is because if I did plug a 3 into that denominator, I would get 3 minus 3, and I would get 0 in the denominator. So therefore, we have to restrict the number 3 from ever being evaluated. So what I mean by this, you guys, is that I'm not allowed to evaluate f of 3 for x right here because it's not in the domain. So the way that we represent the domain is using set notation, and we're going to say that the domain is all real numbers x such that x is not equal to the number 3. So this is the answer, and this is how we're going to represent our answer. We're going to use set notation for this section. Let's take a look at example B. It says g of x is equal to x over x squared minus 9. The numerator represents the p of x of the rational function. The denominator represents the q of x. So I have a polynomial divided by a polynomial. You'll notice in this case that my denominator, the one that I'm looking for to find the domain, is not factored. So we want to go ahead and factor that first. So I can rewrite g of x as equal to x divided by, hopefully you're recognizing this is the difference of 2 squares, so x plus 3 times x minus 3. Once I have my denominator factored, I go ahead and I set them equal to 0, and I solve, and I find the values of x that will give me a 0 in the denominator. So I can clearly see from this one that x is not allowed to be a negative 3. I can clearly see from this one that x is not allowed to be the number 3. So therefore, the domain is represented as all real numbers x, such that x is not equal to, you guys can just put plus or minus 3. And this is the right answer and the way that we're going to represent the answer for part B. Okay, part C says h of x is equal to x plus 3 over x squared plus 9. Again, the top part represents the p of x, and the denominator part represents the q of x. So we want to set q of x equal to 0 and solve whenever we're trying to find the domain. But you'll notice that in this case, no matter what we do, even if I said x squared plus 9 equal to 0 and solved, I would get x squared is equal to negative 9, so x is equal to plus or minus 3i. These are imaginary numbers, and when we're dealing with rational functions, we only care about real numbers for their domain. So in this particular case, everyone, the domain is going to be all real numbers, and we would represent it just like this. All real numbers, meaning that I'm allowed to evaluate this function for any real number that I want, because I'm never going to get a 0 in the denominator. Okay, box 3 is a U-try. Go ahead and find the domain for the following rational function. Hopefully you got the right answer. You realize that x minus 5 in the denominator, set that equal to 0 and get x equals 5. So therefore, the domain is all real numbers x such that x is not equal to 5. Box number 4 is another U-try. Go ahead and find the domain for the following rational function. Okay, hopefully you got the answer of all real numbers x such that x is not equal to plus or minus 5. The way that you get that is you take a look at the denominator. You recognize that that's the difference of two squares. So you factor correctly to the difference of two squares and solve for 0. And there is your answer written in set notation.